Now we're looking at some simple harmonic, simple harmonic, we're looking at projectile motion and some harder questions here. So we've got, the first one is a particle's projected with a speed v and angle of elevation alpha, and the horizontal range where r is less than v squared on g. Show that there is two possible angles for the direction of r, and that if alpha 1 and alpha 2 are those two angles, then you can add them to give you pi and 2. So our velocity diagram looks like that. Our particle moves and is projected, range of r there. So we're able to establish these two equations. We haven't done it, but you know how to get to these two equations. Vt cos alpha, what was established there, and Vt sine alpha minus Gt squared on 2, because it's starting from the origin with these conditions. Now we know when the particle hits the ground, x is equal to r and y is equal to 0. So we get, because that's the point, r0. So that's where we get those two. So if we sub y is equal to 0, we can get Vt sine alpha minus Gt squared. We factorise a t out, and we get 0, which we're going to ignore. And we get the v sine alpha minus gt on 2, which we rearrange to get t by itself. And then we're able to get t is equal to 2 on g v sine alpha. So there's our first part that we needed. And then we get r is also equal to vt cos alpha. So we can sub t in there. It's going to be 1, because if we get either one of them, it's not going to work. So it's always going to be less than 1 here. Then we can say that gr on v squared must be less than 1. If those two are equal, that must be less than 1. And we can establish that r is less than v squared on g. Now if that's the case, we can take the inverse sign, and 2 alpha is going to be equal to that statement there, because we've just done our general formula for that. So we've got a general solution, and we know that alpha is between 0 and pi and 2, so 2 alpha would have to be between 0 and pi. Now if that's the case, we can solve 2 alpha being equal to inverse sine of gr on v squared, because that's in the first quadrant. In the second quadrant, we'll have pi minus inverse sine of gr on v squared. So we're going to have those two, because we're going to only have solutions in the first two quadrants. Then we can get alpha 1 being a half of inverse sine of gr on v squared, and alpha 2 is pi minus half of inverse sine of gr on v squared, which means if we add them together, there's our two angles, and if we add them together, then those parts would cancel, will leave us pi on 2, which is what we wanted to prove. So there's our first one done. Have a look at the next one. This time, speed v, and then those two angles of elevation, and the horizontal range again is r is less than v squared on g that we just saw, and t1 and t2 are the respective height. h1 and h2 are the greatest height reached. Then we can get that situation. So after t seconds, we know we have these two statements. We know we can so we can say that t is equal to x on v cos alpha. So hence, when at the two times when it meets, we get t1's r1 on v cos alpha 2. We're going to have the other one that goes higher. If we multiply those two, we get r squared is equal to v squared cos alpha 1 cos alpha 2. Now we start to manipulate that. We can break it down back into this form when we do our double angles. So alpha 1, cos alpha 1, cos alpha 2 can be written as cos alpha 2 on alpha 1, and out the front, which is where our 2 comes out there. So these two we just proved in the last question. When we've got those two angles at the point R, that gives us that point R there. We're going to get the sum of those to be 0. So because that'll be pi 2 plus alpha. Which is nice. Because of simplify down just to sine of inverse sine of gr on v squared. So we just get the 2 on gr on v squared. We can then start to clean that up. Our r's will cancel, v squareds will cancel, and we get 2g on r, which leaves us with the r, the half g t1 t2 that we need to find. So have a look through how the manipulation came about there. Again, not easy to get those, but see if we can realise what's happening there, how we can eliminate the alpha 1 plus alpha 2 plus alpha 1 from the previous question that we saw, and we can get these manipulations happening, the difference in the two angles, and we can then solve what we need using the complementary angle.